Greetings, everyone. I'm Patrick Veazey with NC State. Today, we're going to be continuing our discussion on substrate pH and all of the different factors that can impact that over time. Today, we're going to be focusing in on substrate components and how those can dramatically impact your substrate pH over time. So what are some of the big considerations when selecting a substrate? What's the optimal pH of your selected crops that you're going to be growing in this? If you're growing something that prefers more of an acidic environment, you're going to want something that has a lower acidity starting out and lower limestone. What's your initial substrate pH and buffering capacity? Lowering that lime charge, you will lower your initial pH, but you lose a little bit of that buffering capacity. Kind of looking into pairing your water quality with a substrate that's going to complement that is very important, as well as pairing it with the correct fertilizer type and rate. Not all substrates are created equally, so customizing your growing practices to match your substrate is very important. Shown here are some of the very popular growing components. We have bark, coconut coir, peat, and wood fiber. And you can't treat all of these the same, so modifying your practices to your substrate is very important. So what are the pH of the raw components? They vary widely, and especially when we blend these at different ratios, you need to account for that in terms of how you manage that substrate. So peat is very acidic, ranging from a pH of 3 to 5. And we commonly add that with perlite, but also limestone. Then we have bark of 4.5 to 6.5, which you would add a little bit less limestone in order to not drive the pH too high. And then coconut coir is slightly acidic to almost neutral, ranging from 5.6 to 6.9. And then wood fiber can range from very acidic all the way up to almost neutral to basic, depending upon the species that's utilized. We add that limestone to raise the pH to a desired set point. But once you get into these different blends of 80% peat, 30%, 20% wood fiber, so on and so forth, you have to manage these all slightly differently. And knowing how these are going to impact your substrate pH over time is very important. So your limestone additions, you can kind of look at it two ways. The required lime is added to neutralize the acidity and increase your buffering capacity and provide calcium magnesium to the crop. Your residual lime is your portion of unreacted limestone following the neutralization of that acidity up to a certain point. We have three common lime forms of calcitic, dolomitic, and hydrated lime. Calcitic and dolomitic lime are the ones that are mainly added into substrates, but you can use any to create a set point pH that you are looking for. And they all have different reactivities. So understanding which lime is used, the rate, and the particle size is very important. Now, what are the needs of your substrate in terms of fertilizer? A wood substrate with bark or wood fiber may require an increase of nitrogen fertility rate to get the same amount of growth as you would see with a peat perlite blend. Using an acidic fertilizer to prevent high pH substrates from that pH increasing, especially with iron inefficient plants such as a petunia, can be very important. So looking here, we have a potential basicity or acidity per ton. You can see that it's all really dependent upon that ammoniacal nitrogen rate. So if you increase that ammoniacal nitrogen of NH4, you get a higher potential acidity as well. And then overwatering, especially in alternative substrates, this is a very important thing that we're seeing, where that surface drying will occur just that top half inch of the pot. However, that lower portion of the pot is still highly saturated. So by visual inspection, you're going to think that that pot is going to need more water, and you're continually dumping fertilizer salts and water into that pot. And we're going to see changes in pH that way. So training in terms of picking up the pots in order to determine the need for watering is very important. We commonly see this with coconut coir and wood fiber, more towards so is peat. So it's, with these new alternative substrates, it's changing your managing practices for that substrate. It's not that the substrate is problematic. It's more of just understanding different management styles. So in summary, your Substrate components have a direct impact on that substrate pH initially. And then picking a fertilizer type to complement your substrate pH is very important, especially if it's a wood-based substrate or something that's going to see nitrogen immobilization occurring. And then being aware of surface drying and overwatering can drastically shift your substrate pH. And with that, we'll go into more into fertilizer rates in the next video. And thank you, everyone.